All right, so I wanted to do this one problem from one of the books here about dealing with the distance formula and the sphere formula in 3D space. So the problem asks us we have a sphere that is centered in the first octant. The distance from the sphere to the origin is 3 minus rad 3, and we want to find the equation of the sphere. So I've drawn the sphere in 2 dimensions, so you can imagine that it really doesn't matter, but you can imagine that this is the z-axis here, and this is the y-axis, and we're also going to and we're going to mark the place where the center is, and we're going to talk about that place, and then we're also going to look at what that means in the scheme of things um, for the information that's been given to us. So, all right. So, what do I know about the sphere? Well, since it's butted up against all of the planes of the first octant, the distance from the center to those planes, well, that's r, and so that tells me then that the center of the sphere is all r's. So it's r comma r comma r. Okay, so that's going to be the center. And I can use that to help me out here in just a minute. I also know that from the origin to the sphere here, this length right here, that's the 3 minus rad 3. And then this length right here is r. And then what I'm going to do is I'm going to call this length right here, I'm going to call that d. Okay, so now what do I know? Well, I know that d is equal to, well, just immediately it's equal to r plus 3 minus rad 3. Pretty easy idea there to work with. What else do I know? Well, I also know that it is a what do you call it? There's a distance formula that we can use on the from the origin to the center. And if we do that, we get another equation for d. And so let's take a look at that. So d is equal to the square root of, well, it's just the distance from each component in the center and each component in the origin, the differences of those squared. So r minus 0 squared. And we're going to have that 3 times. All right, so now if I simplify this up, I get that d is equal to the square root of 3 r squareds. And so, when we're solving anything at all, we really want to, find equations and look at the number of unknowns we've got. So right up here, I've got this d equals r plus 3 minus rad 3. There's 2 unknowns. And here's a totally different equation for d. Is equal to the square root of 3r squared. And so now, since I've got 2 unknowns in each equation and they're both related, that means I can solve it because I've got 2 equations with 2 unknowns. So putting those together, I get that the square root of 3r squared is equal to r plus 3 minus rad 3. And so with this, now I can solve this. I can solve this for r. And it's not terribly easy, but it's definitely doable. So I'm going to square both sides here. And on this left-hand side, I just get 3r squared. And then on this right-hand side, so what I'm going to do is I'm going to take and group this last irrational binomial. So it makes it a little easier to square it. So I get r squared, and then I get plus, and then I get the outer, so r times 3 minus rad 3, plus the inner, so again, r times 3 minus rad 3, and then plus that binomial squared. Let's get one more room here. So 3 minus rad 3, and that quantity squared. All right, so we've got some cleanup to do here. And still getting used to the buttons here. All right, so we've got 3r squared is equal to r squared plus, and so we've got 2r times 3 minus rad 3. So I could go ahead and distribute that. Maybe I'll do that in a minute here. And then we're going to square out 3 minus rad 3. So 3 times 3 is 9. And then we have minus 3 rad 3, minus another 3 rad 3, and then plus 3 for squaring out that binomial. All right, so now let's take and get all of our like terms together. And we'll go ahead and probably get everything over to the left-hand side here. So we get 3r squared, and then minus r squared, and then minus 2r times 3 minus rad 3, and then minus 12, and then plus 6 rad 3. And that's equal to 0 at this point. Clean it up one more time here, or maybe 2 more times. So I got 2r squared, so on. And I notice that everything's got a 2 in it. So let's go ahead and divide everything by 2. Don't have to, but it should make our life a little bit easier as we move forward. All right, so now we've got to use the quadratic formula to help us solve this quadratic. So this term right here is b, and then if we make that, well, plus the negative, right? And then this right here is akin to c. So r is equal to the opposite of b, so that is going to be 3 minus rad 3, plus or minus the square root of b squared minus 4 times a times c, which is negative 6 plus 3 rad 3. All right, and then all over 2a, but since a is 1, this will be 2. Okay, so make sure we got everything right. These are places where signs can get messed up pretty easily, but everything looks good at the moment. And I'm just thinking about this c value here. If I pull the negative out, I get 6 minus 3 rad 3, but I've got that negative in there. So anyways, that should all be right. Okay, so now carry on with the really the arithmetic at this point. So r equals 3 minus rad 3 plus or minus the square root of, so we have 3 minus rad 3, and then I'm going to go ahead and distribute the negative 4 in. So we get plus 24, and then minus 12 rad 3 there, and then all over, oh, you know what? I forgot to square that. So let's do that real fast, because that is going to be important. Should be able to fit that in there. I've done this before, so it's 9 minus 6 rad 3 plus 3. Okay. All over 2. You can hear it in the comments now. Hey, you forgot to square that. All right, so now we've got the square root of. So 9 plus 24 gives me 33. And then minus 6 rad 3. Oh, plus 3 there. So 9 plus 3 plus 24, so that is 36. And then minus 6 rad 3 minus 12 rad 3, so that's minus 18 rad 3 all over 2. All right, so now what do I get here? So I get well, I can take out an 18 out of both of these, and then I get something there. But really, it could be done at any point here. 9 is in common with both of those, so if I take out the 9 out of those and then take the square root of that, so I get 3 times the square root of 4 minus 2 rad 3 all over 2. So there's your radius, and it's also happens to be the value of the center. So then you would just fill in that the equation of a sphere with that r value, and definitely not very nice. We should probably see whether or not we need the positive and negative side. My feeling is it's going to be the positive side that we're going to need. 3 minus rad 3 is definitely positive, and then 4 minus this times minus 2 rad 3, that is also positive. It's like 0.54, and 3 times that, so you get 1.607. So 3 minus rad 3 plus or minus is approximately 1.607. And 3 minus rad 3 is, that is going to be something smaller than 1.607. So this is 268 plus or minus 1.607 all over 2. And so we don't want a negative radius. And we're in the first octant, so we've got to take out the negative. So take out the negative there. So our final r value is 3 minus rad 3 plus 3 rad 4 minus 2 rad 3 all over 2. So hopefully I didn't make any arithmetic mistakes there, but that is the final answer there. And fill that in into your spherical equation, and you'll be good. The reason I did this is because I want you to think about the different pieces that you have and the relationship between the things that you know and the equations that you have, because that's going to be very valuable as we move forward.